Welcome to this explainer. Today, we're taking on what is honestly one of the most stubborn, headache-inducing challenges in modern manufacturing, bridging that notorious gap between IT and OT. We're going to be unpacking some brilliant insights from John Catchett's white paper, Implementing ISA95 with IPE. Look, if you've ever watched a multi-million-dollar systems integration project completely crumble under the weight of bad data, well, you know exactly how frustrating this is. Okay, let's dive into this.
Here is our roadmap for today. We'll start with the IT/OT integration gap, then look at architecture without execution. After that, we'll walk through the 6 IPE steps, map that architecture to execution, and wrap up with process and the AI era. Section 1. The IT/OT integration gap, the missing puzzle piece.
So, we all know the fundamental conflict here, right? Enterprise top-floor systems are constantly, almost chronically, struggling to integrate with plant floor environments. I really want you to think about your own operations for just a second. Why is it that technically sound integration projects, the ones where the code is absolutely flawless and the APIs are beautifully configured, why do they still fail? You invest literal millions, yet 6 months post-go-live, you're looking at missing data and super frustrated operators. Why?
Well, the answer usually lies in a few common failure modes. When we look really closely, a pretty clear pattern emerges. Upstream processes aren't tightly controlled, and that leads directly to data quality degradation. There's no formal change control, which causes integration maintenance breakdowns. IT and OT are essentially speaking entirely different languages, creating major organizational clashes. Add in some flawed measurement strategies, and ultimately, operator adoption just fails. People revert to manual workarounds that corrupt the whole information model. The big takeaway here? These are organizational and process-driven failures, not technical ones.
Moving on to Section 2, Architecture without Execution, and Understanding ISA95's Limits.
To really understand the solution, we have to look at the global gold standard, ISA95. Now, this standard beautifully organizes manufacturing into 5 distinct hierarchical levels. It scales all the way from level 0 physical assets, your actual machinery, up through sensors and PLCs, into level 3 manufacturing operations management, and finally up to level 4 business planning and ERPs. The real magic of this standard happens right at that critical interface between level 3 and level 4, meticulously defining the data exchanged between the plant floor and the enterprise.
Now, what's really interesting here is the crucial distinction being made. ISA95 absolutely defines the architecture, but it intentionally leaves execution completely out of scope. It's an incredibly robust blueprint for defining exactly what information must be exchanged, but it does not prescribe how an organization actually deploys or sustains the everyday human behaviors that populate that data. And to be clear, that's not a flaw in the standard, it's just outside its scope.
And this perfectly illustrates the dynamic we really need to master. On one hand, ISA95 is essentially your plumbing. It's the rigid technical blueprint. But on the other hand, we have the fluid, human-driven daily operations. This is where the Integrated Process Excellence Framework, or IPE, comes in as the ultimate bridge between the two. It delivers the operational discipline and the daily OT habits you actually need to make that IT blueprint work in the real world.
Section 3. The 6 IPE steps, a structured methodology.
Rooted in Roger Slater's 1996 work, IPE is definitely not just another consulting gig. It's a highly repeatable, deployable system for organizational effectiveness. Here is how it brings that technical standard to life. First, you establish a positive environment and cross-functional alignment. Second, you strictly define your process. Third, you document it. Fourth is communication, getting everyone on the exact same page. Fifth, you install a robust measure and control system. And finally, step 6 locks the whole shebang in with continuous improvement. Now, a massive accelerator for step 3 in that process is something called IPE Packs. These are honestly incredible. They're pre-built, AI-enhanced libraries of process documentation, like SOPs and KPIs, structured in a strict 3-level hierarchy: area, activity, and element. Just think about the power of this for a second. Whether you're in injection molding or pharmaceutical manufacturing, you are not starting from scratch. You take these pre-validated libraries and just configure them to your site. It is an absolute game changer for speeding up deployment.
Let's move to and see how this builds in Section 4, Mapping Architecture to Execution, Connecting the Frameworks. The alignment between these frameworks is almost perfectly one-to-one. ISA95 Part 3 defines 4 core domains at Level 3:
production, quality, maintenance, and inventory. And because IP packs are structured to align directly with those specific domains, deployment is incredibly seamless. The abstract models defined in the standard are instantly backed up by concrete, executable documentation for your workforce. We're talking actual inspection instructions for quality or PM workflows for maintenance.
So once it's documented, you absolutely have to measure it. This brings us to step 5, the KIV, KPV, KOV causal architecture. Normally, when an integration fails, we just sort of count the system errors, but that's totally reactive. IPE separates the variables to help you find true root causes. Key input variables look at things like operator trigger conditions. Key process variables look at execution rates. And key output variables look at your schedule adherence. If an order fails, this causal setup instantly tells you if the culprit was a bad upstream human input or just a technical transaction error.
For step 6, continuous improvement, IPE utilizes SMEA. That stands for Success Mode and Effects Analysis. You're probably familiar with FMEA, which analyzes failures. Well, SMEA completely flips that on its head. It systematically defines and measures the conditions for successful integration before a failure ever even occurs. It's this fantastic proactive safety net that perfectly complements your architecture, letting you safely evolve as your environment changes.
Section 5. Process in the AI Era, Preparing for Industry 4.0. To survive Industry 4.0, we obviously have to adapt. So the crucial point is captured beautifully in this one simple axiom: data plus process equals AI ROI. AI tools, whether we're talking about predictive maintenance or intelligent schedulers, are entirely dependent on the quality of your process data. I mean, think about it. Your fancy predictive model is completely useless if the underlying data flowing from level 3 is just garbage.
In this modern, smart manufacturing environment, IPE essentially becomes your AI process layer. It standardizes your AI training data so the models actually learn how work should be done, not just the historical bad habits of your plant floor. By using that causal measurement architecture we just talked about, it helps AI distinguish a real signal from mere operational noise. And most importantly, it ensures that those model insights actually translate into physical process changes, rather than just becoming another expensive dashboard that literally nobody ever looks at.
Furthermore, IPE tackles some massive emerging compliance challenges. They've actually mapped out an AI risk periodic table, detailing 70 named AI risks across 9 categories. If you are operating in a heavily regulated space, like pharma facing strict FDA enforcement, this provides exactly the kind of rigorous risk governance you need to deploy AI responsibly across that enterprise control boundary.
To wrap things up, I want to leave you with this question to really chew on. Is your digital transformation actually ready for the execution test? We spend so much capital perfecting the ISA95 blueprint, but as John Kachat clearly shows us, architecture alone isn't enough. IPE delivers the operational excellence required to actually sustain it. Because at the end of the day, architecture without execution is really just a very expensive piece of paper. Thank you so much for joining me on this explainer, and I highly encourage you to look deeper into integrating IPE into your own operations.